Hi, I'm Senior Scientist Miika Rämä from VTT Technical Research Center of Finland, going to hold you a presentation on district heating as a solution for heat supply. So here are the presentation contents. First I'm going to describe the main elements in a district heating system. Then I'm going to discuss district heating system operation and control, then something more on production, distribution and consumption within a district heating system. Then some examples of different kinds of system designs, and lastly a summary. So the aim of this first slide is to describe the main elements in a district heating system as a starting point for the presentation. So all buildings in cold climate require heating. This consumption of heat is due to thermal losses through the building envelope, ventilation heat load and domestic hot water. This consumption of heat needs to be satisfied by the source of heat. In district heating, the produced heat is distributed to the consumers through a network of insulated pipes. However, both conversion and distribution have losses. District heating networks often form numerous branches and loops as visible in this example network layout from a small Finnish town. District heat is sometimes referred as a source of heat, but it's rather a technology for distributing the heat produced in the most efficient way possible. So how a district heating system with these three familiar main elements actually works? Heat consumption depends mainly on outdoor temperature due to thermal losses. The outdoor temperature is also an input for the control system regulating temperatures in a heat distribution system within a building, supplying heat to the heated space itself. This internal circulation is referred as secondary side, opposed to the district heating network, which is referred as primary side. Outdoor temperature also often is used as an input for controlling the supply temperature at the production plant. In cold weather, higher supply temperatures are used. There are always some heat losses in the distribution network, so the supply temperature experienced by a consumer is lower than at the production plant. Flow of water in the network is controlled by a valve at the consumer. Mass flow, heat demand, supply temperature, and temperatures on the secondary side result in a certain return temperature at the consumer. In the distribution network, the mass flow causes a pressure drop in the network, resulting in a certain pressure at the production plant. The return temperature is affected by the heat losses just like on the supply side. The pressure control system and pumps maintain a certain pressure level in the system to avoid boiling in high supply temperatures. District heating is not tied to a certain production technology. Options include combustion in combined heat and power production or in boilers, renewable energy options, heat pumps, heat storages, utilization of waste heat from, for example, industry. Some technologies are more suitable for providing base, variable, or backup load than others, or have other characteristics influencing their utilization. A smart combination of different heat sources is needed. In distribution, the temperature level is the most defining factor in the operation of the system. So temperatures range from over 150 degrees of Celsius to as low as 40 degrees of Celsius. The current trend is towards low temperature solutions, as more heat can be extracted from low temperature heat sources and distribution has lower heat losses. Consumers require a solution for connecting to the district heating system. This is usually done either directly, primary side water flows through, for example, radiators of the building, or indirectly using a substation with heat exchangers between the primary and secondary sides. Direct connection is more simple, but indirect is often more efficient. Heat distribution inside a building can be done by radiators, like in the picture, or floor heating or ventilation-based heating. So substation connects the district heating network to the heat distribution system within a building using heat exchangers. In this example, one for heating and one for domestic hot water. So hot district heating flow is regulated by valves. Return flow from the heating heat exchanger can be used to preheat cold water for domestic hot water supply. After the heat exchangers, district heating water returns to the network. Heat distribution system on the secondary side can be, for example, radiators or floor heating. For domestic hot water supply, cold water flows through the heat exchanger and is heated up to a defined temperature. A separate circulation enables an acceptable response time for hot water supply in larger buildings. That is, you get hot water service almost immediately when you turn on a tap. This valve is controlled to reach the set temperature for domestic hot water supply. Same goes for heating here. A valve controls the flow according to the set point on the secondary side supply temperature. Cold water valve opens when hot tap water is used, that is, pressure drops within the circulation. This connection is just a single example of a substation connection, although common. Substation can also accommodate control monitor auxiliary heat sources such as solar collectors. So different kinds of district heating system designs exist. There is lots of variation in design. So Finland has a very well developed system with indirect connection of consumers using building specific substations. Control systems are an integral part of the design, and the CHP share is very high, over 90% of produced heat. In China, temperature levels are higher. Substations do exist, but they are called group substations, servicing several buildings with heat demand measured in megawatts. Control systems are often not present. Iceland has a system based on geothermal heat. The special characteristic of the system is that it only has a supply pipe after the consumer's water is injected into the sea. Denmark has maybe the most variation in design. Like in Finland, CHP production is common, low temperature distribution is also common, and number of small local systems is high. So lastly, a summary of the presentation. District heating consists of production of heat, distribution network, and consumers with equipment for heat distribution. Basic idea is to generate heat as efficiently as possible. Lots of different technologies for production exist, and the one suited for local conditions and resources should be chosen. It's a capital-intensive infrastructure type of investment, mainly due to the pipe network. From a consumer point of view, it's reliable and requires minimal amount of maintenance. Thank you for your attention.